So in this example we have to find the slope of the line that's shown below. And we can see that there are 2 points identified on the line. The 2 points are -3, 2 and 4, -1. Okay, now we're going to label one of these points as x1, y1 and the other one is x2, y2. And it doesn't make any difference which one is x1, y1 or which one is x2, y2. When you're finding the slope of a line, it doesn't matter the order in which you call one x1, y1 and the other one x1, x2, y2. Okay, so let's label these and do that part carefully. So the first one has got to be labeled x1 and y1. The second one labeled x2 and y2. Now, the labeling should be written down like this because what you can't afford to do is get mixed up later on. Okay? The slope formula is m, and for slope is y2 minus y1 over x2 minus x1. And if you think about it, just a little aside here, if you think about it, that's the change in y, so delta y, over the change in x, delta x. So it's really the rate of change formula. The slope formula and the rate of change formula are the same thing, which tells you that rate of change and slope are actually the same thing. Okay, the rate of change in a real life situation, the rate of change of one quantity with respect to another, can be modeled graphically by the slope. Basically 2 different ways of looking at the same thing. Anyway, back to this question. Let's start filling in the y's and the x's. y2 is -1, minus y1 is 2, over x2 is 4, minus x1 is -3. Okay, now we have 2 signs coming together here and we do not like that, so let's try and take care of that. So it's going to be -1 minus 2 on top, and 4 minus -3. We don't like 2 signs coming together. 2 minuses coming together is the same as a plus, so that's 4 plus 3. So that's really what's going on there. So that means that the slope is going to be -1 minus 2 is -3, and 4 plus 3 is 7. So the slope is -3 over 7. And we usually like to leave slopes in fractional forms where they are fractions. So the slope here is -3 over 7. Let's look back a couple of things. We've got that the slope is negative, and when we look at this line, and we follow this line from left to right, it is going downhill, so that would be correct. That would confirm that the slope should be negative. Okay? And the other thing we can do is we can relate this to the very first slope formula you ever dealt with, which was rise over run. And if you think about rise over run here, what we'll do, we can drop this down here and then go across. So we come straight down and then straight across. Start at one point, come straight down, straight across the other point. We came down 1, 2, 3 squares. Okay, so we came down 3, so -3 for coming down. And then we went over 1, 2, 3, 4, 5, 6, 7 squares. So we went 7 squares to the right. Okay, so we came down 3. So the run is -3 because we came down. Sorry, that's the rise. Beg your pardon. That's the rise. The rise is -3. The run is how far you move towards the right. Okay, and we moved 7 steps towards the right. Okay, 7 squares towards the right. So the old slope formula, rise over run, would be -3 over 7. So that would work as well. That one works as well. It's just if you don't have the graph, this one always works. Okay, if you don't have the graph, this is what you use. Okay, so what have we taken from this? We've taken the slope formula works. Lines going downhill are negative, have a negative slope in other words. The y2 minus y1 over x2 minus x1 works just as well as the rise over run formula. They'll always give you the same answer. Rise over run is okay if you have a graph, but if you don't have a graph, then y2 minus y1 over x2 minus x1 is better. And that's basically, the slope formula is basically the same formula as the rate of change formula. So slope is a graphical representation of rate of change. It's another way of showing you the rate of change, or to be more correct, average rate of change. Okay, so there's a lot there, but what I want you to concentrate on is how do you use the y2 minus y1 over x2 minus x1 formula. Okay, thanks for sticking with it.